Hello calculus friends! Welcome to another lesson. Today our objective is to find derivatives of inverse trig functions. So once again the idea here with derivatives is to take new functions and be able to differentiate them. So like we did initially with just the trig functions, we have more derivatives, we can do more things in math with that. So one thing that we haven't done yet is inverse trig. So a little notation, inverse trig, you're probably thinking notation like this. Remember that means inverse, not to the negative 1 power. And because that's confusing, some people use arc sine, or arc cosine, arc tangent, arc secant. You get the idea. So this is what we're working with. This notation is interchangeable. But remember, inverse trig, you put in a ratio and you get out an angle. So inverse sine of, say, 1/2 would give out pi over 6. Or arc sine of root 2 over 2, you should be thinking pi over 4. That's how those work. And we are going to take the derivative. So let's start with that. First question would be, what do you do with that? We really don't know how to take the derivative. That's what we're trying to do. So we've got to use something maybe algebraically and creatively so we can find a derivative for this. If you've done logarithmic differentiation, the idea here is the same. In logarithmic differentiation, you take the log of both sides. Here we're going to take the sine of both sides. So sine y equals the sine of arc sine of x. Well, those are inverse operations, inverse functions. We'll get our x on the right side. So that's taking sine of both sides. Now let's differentiate with respect to x. I'll do the right side, you can do the left side. Just kidding, I'll help you out. So sine u, this is implicit differentiation. We've got sine of u, but we're doing it with respect to x, the variables don't agree. So the derivative of sine u is cosine u times u prime. Y prime in this case. Well, here's our derivative, let's solve for it. So let's divide both sides by a cosine y, which is the same as multiplying by secant y. So the derivative is equal to secant y. But that's not ideal because we want this to depend on x. So let's do a little trigonometry. So unit circle, SOHCAHTOA type stuff. Our angle is y. Our angle is y. That hasn't changed. Forgive me if I'm a little slow on this, it's been a while. And our ratio is x. So y, the angle y is given by that ratio. And sine is opposite to adjacent, has to give us x. So opposite to adjacent, x over 1. That would get it done. Now you use a little Pythagorean theorem to get the third side. X squared plus something squared has to equal 1 squared, or in other words 1 squared minus x squared would give us this squared. Any way you do it, you would get 1 minus x, or root 1 minus x squared for that side. So that's a little tricky, but realize y is the angle, x is the ratio, and that's the sine ratio. This is really the only triangle that can work. Okay, now we have to take the secant of that angle. Secant is cosine, the reciprocal of cosine. So cosine is adjacent to hypotenuse, this one to that one. So flip it, we're going to go with this hypotenuse over the adjacent. And that would be our derivative. The derivative is 1 over root 1 minus x squared. Non-obvious that that guy's derivative is given by this. We could generalize that, that's where we go next. The derivative of arc sine u is the generalization. That'd be 1 over root 1 minus u squared times u prime. So we're just going to put that u prime on top. And that's how all these work, really. Arc tangent, we could do that one in a similar way. But the idea here would be to probably memorize these formulas. You probably don't want to go through this process on a test to get a derivative, but memorize it. There you go. Let's do one more for fun. So we get the process down. Let's do that arc tangent. It's been a while for me. So y equals arc tangent x. Take the tangent of both sides. Then we take the derivative with respect to x. Right side is 1, left side. Tangent u, derivative of tangent u, it's going to be secant squared u times u prime. Dividing u prime. Dividing by secant squared would be the same as multiplying by cosine squared. And now make the triangle. The angle is y. Hopefully the second time through the process is becoming a little more clear. And you could do these if you had to explain to a friend how you'd go about it. The ratio is tangent, and the given ratio is x here, so tangent is opposite to adjacent. So opposite to adjacent, x to 1 gets it done. And now Pythagorean theorem, 1 squared plus x squared equals that side squared. That'd work. And now let's finish it up by taking the cosine of that and squaring it. So cosine is adjacent to hypotenuse, so then we've got to square it. So 1 squared is 1, and the root and the square cancel each other out. So 1 plus x squared, or x squared plus 1, however you want to write that. That's the derivative of arctan x, or inverse tangent of x. Could generalize that. Derivative of arctan u would be 1 over 1 plus u squared times u prime. So put the u prime up there. And there's 2 of 6. So the other 4 trig functions, same idea. This is somewhat unique in that you start with something that's inverse trig and you end with something that's algebraic. In other words, we're only using squaring and multiplying and dividing and addition and roots to get that right side. A little unexpected, but that is it. So hopefully now you will be able to find derivatives of inverse trig functions. What you want to do is look at a section in the book or Google inverse derivatives of inverse trig functions, and you'll come up with the other 4. Or a good exercise would be prove those other 4 on your own. See if you can come up with those formulas and then check them with some sort of resource. So that's it for the day, short and sweet. And remember, you know your calculus, u plus me equals us.